Welcome. So today we will be covering a review of domain, range, increasing and decreasing intervals, and relative maximum and minimum. You're welcome to follow along in the worksheet provided. There'll be some space for you to write down the definitions that I write on my screen here. I'll go over an example or two, and then there'll be a place for you to try an example on your own on the worksheet, and then I'll place the answers on the screen provided. So first, we're going to talk about domain. Again, this is a review, so some of y'all might already have notes pre-written down, and that's fine. We're going to write general vocabulary about each. So for first domain, we have the set of all possible inputs. That's the official definition. Another way to look at domain is the X value. The X value on the graph. Now for range, we have the set of all possible outputs. Output, or we look at it as the Y value on the graph. Really, the important thing that we want to remember is that domain deals with X, range deals with Y. So we're going to practice a discrete domain. So we are given 4 points here. We are given 1, 2, 3, 6, 4, -1, and 5, -2. So if I were to write these out, right, 1, 2, 3, 6, 4, -1, and 5, -2. If you guys remember, a point is always X, Y. So our domain is going to be our X values. Saying that our domain is going to be equal to 1, 3, 4, and 5, because that is the X values of all of our points. Similarly, if we are looking for the range of each of these points here, and I were to write them out similarly, so I have 1, 2, 3, 6, 4, -1, and 5, -2. Again, a point is always X, Y. All of our Y values are here. So our final answer would be 2, 6, 2, 6, -1, and -2. All right. Now that I've given this example, we're going to have you try one on your own. So given the 4 points here, here, and here, you could pause this video, find the domain, and find the range on your own on the worksheet that you guys were given. So I'll pause for about 3 seconds, and then I'll give you the answer here on the screen. So for our domain here, we are going to have 1, 2, 4, and 6. And for our range, we're going to look at the Y values of each point. So that gives us 4, 3, -1, and -2. So I wrote these in order as I saw them for each point. On your test, you might get them in numerical order. So it might go -1 or -2, -1, 3, and then 4. Both are correct. Next, we're going to move on to, this is domain of continuous. You guys would have covered this in the second day of your notes. Continuous just means we are looking at a function where all the points are connected somehow. So if you were to take your pencil and start at one point here, and you would be able to follow it all the way around and touch all the other points. Again, domain is x's, so I'm going to write that here. And then our range is still, my apologies, this one is going to be range. All right, and this is going to be y. For domain, we want to ask ourselves with continuous, how far can we go left to right? So I want to ask myself, what is the furthest left or most left I can go on this graph? Well, looking at this circle, this is our left side, and this is the furthest left that this graph exists or goes. Given that this is our x's for domains, we have this point -3, 0. We're going to use the x value. So the furthest left we go is -3. Now we are able to physically touch this point. So we are going to use the less than equal to. Domain is x, less than equal to. And then we want to look at what the rightmost point is. Well, this is the furthest right that we are able to go. Given this point 3, 0, we look at the x value, which is 3. So our furthest we can go is 3. This would be our answer. So domain, we want to make sure we're looking left to right. Now for range, we want to look down to up. We want to know what's the furthest down this goes and what's the furthest up. Again, we are going to use y. We want to start with down because of our numbers. We always go smallest to largest. So the furthest down this goes is this point here. We look at the y value, so it's -3. Again, we are able to touch that point, 0, -3. So we're going to use the less than equal to sign. The highest up we go is at this point, 0, 3. We use the y value of 3. So this would be our answer. Again, domain, you're asking what's the furthest left, getting that point to the furthest right. Range, you're going the furthest down all the way to your furthest up. Okay. Now using the worksheet that you were given, flip to the next question. It should look like this, a circle on your page. I believe your points are here. Let's fix this. Your points are -5, 0. You have 0, 5. You have 5, 0, and you have 0, -5. So I'm gonna give you about 3 seconds. You can pause the video, try the graph on your paper, and then I'll come back and give you the answer. All right, so for our domain, again, we're going from left to right. Our furthest left is this -5 less than equal to x, less than equal to our furthest right of 5. For our range, again, these points change slightly. So it's negative 5, 0, 0, 5, 5, 0 here, and 0, negative 5. We want to go from down to up. So our furthest point or our lowest point on this graph is 0, negative 5. So we're going to start with that. Less than equal to y. Less than equal to our highest point is this 5. So it's going to be positive 5. This is the answer you should have gotten on your sheets. All right, we're going to try one more. Now, when we're looking at the domain of this graph, it's difficult to see. Some of your questions might have it, some of it might not. But these lines here at the very ends go on forever. So I'm going to draw little arrows here, right? Meaning these go up forever. So again, we want to find domain. That is going from left to right. Domain again is X. Now, as we go furthest to our left, this graph is going up forever and to the left forever. So we are going towards negative infinity. On our other side would be positive infinity. So as we are going to the right of this graph, going this way, it's going to go to the right forever. So it's going to go to infinity. Our X goes in the middle, signifying domain. And instead of less than equal to, like we've been using, we are going to use the less than symbols here because we can never touch infinity. Now for range, we are going to look down to up. Down to up. All right. So the furthest down we go is this point here. And that is the y value of negative 4. We can physically touch the negative 4 number with our pen. So we're going to use the less than equal to symbol. Y, because y is range. And then this graph, since it goes up forever, goes up to infinity. So we can't touch infinity. So it's going to be less than infinity. All right. So we're going to try this one on your own. On your paper, you have this exact graph. I'll pause for about 3 seconds so you guys can pause the video. Here, try to find the domain and find the range. All right. So our domain again is left to right. Our furthest left that this goes, this graph will go on forever. So it's going to still be that negative infinity, less than X, less than infinity. Because it goes right forever. Remember, domain is X. I will say that a lot. Now for our range, we go from down to up. The lowest this goes down is 0, 1. Again, we want the y value of that point, which is 1. We can physically touch the 1 with our pen. So we're going to use the less than equal to symbol. Range is y. So y goes in our answer. Less than. This graph goes up forever. And because of that, it's going to be infinity. All right. Check your answers, make sure they look good, and then we're going to move on to increasing and decreasing intervals. So for increasing and decreasing, you guys should have covered this during day 3 notes, so probably the last class. So increasing is where on the graph, let me get mine, where on the graph, your slope is positive. Another way to think of this, when you're looking at the graph, the line or curve will be going up. It'll look something like this. Decreasing is just the opposite. It's where on the graph the slope is negative. Okay. Another way to think of that is when it is going down. All right. So let's do some examples. We want to find the increasing interval and the decreasing interval of our graph. To make this a little easier, I've chosen a graph and given you all the points. So let's start with increasing. Increasing is where our green line here, graph, is going in an upward direction, or our slope is positive. If I were to try and color that, I'm looking at this point here and onward, where I'm coloring yellow, is where our graph is going positive, or our slope is positive. On the other hand, this portion of the green line here that I'm coloring with purple is going downward as we are going from left to right. So if I were to take my pen and drag it all the way across this green line, starting from left to right, it is going downwards. The key important point that we're going to look at is this 0, -4, because that's where it's changing from a decreasing interval to an increasing interval. So an important keynote that you want to write when we're looking at here, when we are doing the answer, all right, when we are doing the answer for increasing and decreasing, we're going to be using, using the X values. And that is very important. We are going to be using the X values. So you'll be looking at a point, using the points, and only using the X values. So let's look at this increasing interval. The yellow part that I've highlighted is the increasing part. Now to add some more features to this graph, to this left side is a negative infinity. The right side is all the way to infinity. I am increasing from this value of 0, -4, but remember we're using the X value, so which is 0. So I would say I am increasing from 0 to infinity. I'm increasing from this point here all the way up as I go from left to right. We go left to right because we always have our smaller numbers come first, just like our number line. Let's look at decreasing. So again, we wrote that if I'm taking my pen and following this line from left to right, it starts here, and this portion that I'm coloring in purple is all decreasing. Again, this is negative infinity over here, infinity over to the right side. So my decreasing interval is going to be from this negative infinity all the way to this point. And again, we're using the X value, which is 0. Right. So on your paper, the worksheet provided, there is an increasing and decreasing question. I'm going to pause for 3 seconds, write down the interval of increasing and then the interval of decreasing, and then I'll provide the answer. All right, for increasing, when I'm looking at this graph here, if we're sticking with the same colors, increasing is a portion of the graph that's going up. From this point 0, 1, I notice that from 0, 1, and as I move my pencil to the right, colored in yellow, all this portions goes up. We have infinity on this side, negative infinity here. So my increasing interval will be from, again, we're using the x value, 0, comma, negative, or 0, comma, positive infinity. As we're moving to decreasing, and I start my pencil on this green line here and move down all the way to 0, 1, we are decreasing what I colored in purple. Since over to the left side starts negative infinity, right side is infinity, we are decreasing from negative infinity to 0. Okay. The last thing that we'll talk about is relative maximum and relative minimum. So both of these, a maximum is a high point and a minimum is a low point. So for their definition, they are a point. Remember, our points are always x, comma, y on our graph. Where the graph changes from increasing to decreasing. Right. So to give you an example, remember decreasing and increasing, we can use the words down and up. So this is where it's important which order it changes from increase to decrease. So if you guys remember, increase is going up, decrease is going down. So if it's changing first from increase, that means we're going up and then we're decreasing down. And it would be the point where they changed. And this kind of, if you think of it like a roller coaster, right? For maximum, you're going up and then down. It's the highest point of our roller coaster. And relative minimum is just the opposite. So it's a point on our graph, x, comma, y, that changes from decreasing to increasing. So again, decreasing is if we were going down first, and then it changes to increasing, which means we're going up. If you were to think of a roller coaster or a slope, it goes down first and then up. So this bottom point would be our relative minimum. Now there can be multiple relative maximums and minimums, depending on how many intervals of increasing, decreasing. It's easiest to think how many little hills or how many little valleys there are. Right, so let's use our first example. So I'm going to color this first from increasing and decreasing using the same colors we had before. So as I drag my pen across this green line, I'm going to use the colors we had before where increasing was yellow, decreasing was purple. So if I start here on our graph, we are going up as we follow this line here. So this yellow portion is going up. The next part from this point given, negative 2.667, comma 11.481. This part is going down in purple, so we are going down. And finally, this last 0.2 onwards, we're going up. So again, our relative maximum is that change from increase to decrease, or it looks like this. And you can see from yellow to purple, it looks similar to our hill shape. So this point here, 2 points, negative 2 point, and we'll say 667, comma 11.481 is our relative max. We're looking at our next point here. We were increasing in this range. We were increasing here. but our middle line was decreasing. A relative minimum is a change from when we were decreasing to increasing. So kind of the bottom of a roller coaster or the bottom of a valley. So our point here, 0, 2 would be a relative minimum. All right, so for your last problem, you're given this function, and I want you to find the relative maximum and then find the relative minimum. So I'll give you about a 3-second pause. You can pause the video, try it on your paper, and then hit play again, and I'll put out the answer. All right. So for our given maximum, I'm looking for a shape that looks similar to this, right? Where it changes from increasing to decreasing. So our relative max is going to be 0, 1. And then our relative minimum is when we're decreasing to increasing. So it'll look similar to here. In this portion of the line, we're decreasing to increasing. So our relative minimum is going to be 2.933, comma, negative 5.31. All right, so that should conclude the review of the first 3 days. And the next video you guys will see should cover X and Y intercepts of a graph.